Okay, here we are. Today we're going to be looking at chapter 11, and the first couple sections are pretty easy, so we're going to be doing both 11.1 and 11.2 in the same day. That's why we had you start out by filling in example 1 and 2 of the notes. You guys filled this in. Here are the answers to that homework piece that you would need then. So essentially your mean is 7.4 minutes by getting 74 over 10 to get a mean of 7.4 minutes. Putting in order, we see that there are two numbers in the middle, so we take the average of that to find the median, which is 7.5 minutes. And the mode is what occurs the most frequently, which was 8 minutes. The range is something else we asked you to find. And I didn't have this written, so if you'd like to write it, you can. The range, you take your max minus your min. So that's what we do in example 2 to find the range of waiting times. In example 1, we take our maximum of 15 minus our min of 2, which gives us a range of 13 minutes. So hopefully that went well for you. There were a couple things that, blanks that I left open up there. Because the U-tries that we're going to do together, we're actually going to use the graphing calculator for. So one of the things I want to fill in is that your mean is denoted by an X with a line over it, and that's read as X bar, and statistically that is talking about the mean. So X bar really means the mean. So in the U-try problems, we are actually going to use our calculators to help us get all of this information. So take a second, and if we need to pause the video, and let's make sure we all have our graphing calculators ready. So now that we have those ready, let's look at the steps. So here, I'll put over here the steps to using the calculator, okay? We're going to start by putting the numbers in a list. Remember, to put numbers in a list, you go the stat and arrow over, well actually it's just right there, stat edit. So that's how you put the numbers in the list. Then we're going to have the calculator do all the computations for us. We're going to press the stat button again, but this time we are going to actually arrow over to calc, and we're going to go to 1, which represents the one variable statistics. You might have to enter the list number. I'd like to practice that with you guys also. And then for the mean, notice that it gives X bar on that screen. So X bar, the mean, will be on that screen. And then you can scroll down for the median. It doesn't tell you the mode, but we can usually eyeball that. And it doesn't tell us the range, but when we scroll down, it'll also tell us the max and min. And so then we can use the max and min and easily subtract. Okay, so that's what we'll do. We're going to put our numbers in a list. We do that by going to the stat button, enter for edit, and entering our numbers. After they're entered, we go to stat calc, one variable stats, and then we'll have our information. So let's try that together with race A. So with race A, we're going to put our values into L1. So in order to do that, we're going to go to the stat, and then notice edit shows up, so I just press enter. Remember, if you have other things, if you have numbers in your list, you can arrow up to L1, press clear, and then enter. And then L1 is still intact and it's clear. So we just enter these in. You can either use the arrow key after each one, or you can press enter after each one. And so I've now entered in all those values for race A, and I put them into L1. So now we can have the calculator do the work for us. The second step is to press the stat button again and go over to calc, and then we want to do one variable stats. And just so that we can use lots of different lists, let's tell it we want it in L1. So to get to L1, you're going to hit the second key and then the number 1, and L1 comes up. If you wanted L2, you'd use the second key and 2, etc. So anyway, it's just telling the calculator what list to look at, and we're telling it we would like it to find the stats in L1. And notice that, right, the first thing that it tells us is this X bar. It tells us the mean. So let's write that down, that in race A, and I'm just going to call it a little X bar sub A. Notice that that's about 8.7 minutes. Okay. Traditionally, we round to like one more unit maybe than they give us often. So since these are integers, we'll round to the nearest tenth. The next thing we can do is find the median. Notice there's a little arrow here. Median doesn't appear on this screen, but if you use your arrow key and scroll down, notice that it gives us the median. So we can tell that the median of A is 9 minutes. Now again, the calculator doesn't tell us the mode, but we should be able to find out what the mode is just by looking at what number appears the most. And I notice 8 appears twice, 9 appears twice, and that's the number that occurs the most, so those are both considered modes. 8 minutes and 9 minutes are modes. Well, next let's look at the range. For our range of data, we are going to subtract the max minus the min, and we can see that our maximum is 12 and our minimum is 4. So we would take 12 minus 4, and that would give us 8 minutes. And that's all you do. So now what I'd like you to do is I'd like you to try the numbers from race B, and I'd like you to put them in L2 and try to find those stats. Okay, so hopefully if you put those numbers in the lists, again, we just go to stat calc, just kidding, stat edit, and then just put those numbers in list 2. And then what you would do is go to stat calc, one variable stats, and then just put second 2 for L2, and then that's how we obtain these values. So what you should have for race B is that the mean of race B is about 7.7 minutes. We can also find that the median of race B is about 8 minutes. Your mode for race B is 8 minutes. Oh, the median is exactly 8 minutes, sorry. The mode is exactly 8 minutes. And then your range of B, taking the 11 minus 5, is 6 minutes. Okay? So that's how you can use your calculators and find the mean and median very quickly instead of doing the work that y'all did last night. Okay? So another thing we're going to look at so those are all measures of central tendency. So those are measures of center. This is asking about a measure of dispersion, which is like the range. The range is a measure of dispersion or a measure of spread. And another measure of dispersion is the standard deviation. And the standard deviation represents the typical distance that a data value is from the mean. So like you have all these different numbers and you have your average, like typically how far away do the numbers vary? That's what standard deviation means. The standard deviation is usually given by this little sign, and it's read as sigma. And the standard deviation is given by this formula. Don't worry about it too much. Each of these represents how far the data values are from the mean. So we like find that distance, square it, whatever. But the good news is that we can just use our calculator. So we can just use our calculator again. It's still in one var stats. And then we'll just look for that sigma. Okay? So if we are doing that, this wants us to find the standard deviation of the waiting times in example 1. So I'm going to leave these in list 1 and list 2 because the U-try wants you to use those same numbers. So let's go over to list 3 and let's put those values in. So 4, 8, 12, 15, 3, 2, 6, 9, 8, 7. And we just enter those values into a list. Just because we're using list 1 and 2 again, I'll keep those in there. And then I'll quit out, and I'm going to go over to stat calc, one variable stats, and this time we're going to go to list 3, so I'll hit second 3 to make it go to list 3. And notice that right here is sigma x, which is 3.8. So that's what we're going to use. And we'll say that sigma, which I make by like making a little circle and then kind of like extending the top, is 3.8 minutes. Okay? So now I'd like you to take a minute and use the values that you have in list 1 and list 2, hopefully, for race A and race B, and find the standard deviation of each of those. So take a second and do that, please. You can pause to give you guys a chance to do that. So please pause. Okay, so here are the standard deviations you should have. The standard deviation of the waiting times in race A, the finishing times in race A is 2.2 minutes, and for race B is about 1.8 minutes. So that's how you find standard deviation. Just use your calculator. If you don't have a graphing calculator, you can even just Google like standard deviation calculator and punch the numbers in and you can find it, okay? All right, so measures of central tendency, which are like measures of center, just to be clear, and dispersion, which is a measure of spread. Sometimes they can give misleading impressions of a data set if the set contains one or more outliers. An outlier is a value that is much greater or much less than most of the other values in a data set. There's a specific formula for it. We don't get into it, unfortunately. But we'll just tell you that you have an outlier and kind of ask like what that does to the data. So this sets to find the mean, median, mode, range, and standard deviation of this data set, which are the winning scores for the first 10 games in an air hockey tournament you're competing in. So we know to find the mean, median, mode, range, and standard deviation, we're just going to put these values in L1. So we're done with these lists. So I'll clear this old list 1, go to L1, arrow up, clear, enter, and then I can put these values in 14, 15, 15, 17, 11, 15, 13, 12, 15, and 13. Something's up. 14, 15, 15, 17, 11, 15, 13, 12, 15. Oops, I had an extra one. Okay. There we go. So here are my 10 data values. And again, to find all of those different pieces, we can go to stat, calc, one variable stats, and this is in L1, so I'll hit second 1. And that'll give me all of these pieces of information. So I can tell that my mean is 14. arrow down. My median is 14.5. Let's see, let's look at the data. The mode, looks like 15 occurs the most. My range, 17 minus 11 would be 6. In my standard deviation, well, I'll arrow back up for that. And I can see that it's about 1.7. So there's that info. And it says the winning score in the next game is an outlier, 3. Find the new mean, median, mode, range, and standard deviation. Well, all it wants us to do is put another value into that list. So let's go back to our list by going to Stat, Edit, and I'm going to scroll to the bottom of the list, or you could arrow up a couple times. And so now instead of 10 values, I'm going to add an 11th value. And so under the 13, I'm going to add a value of 3. And now let's find the new one variable stats of L1. And so now I can see that my new mean is 13. Let's see, my median is 14. My mode, well, that's still 15. My range is now 17 minus 3, which is 14. And the standard deviation is now about 3.5. And so those are my new values. So then it says, which measure of central tendency does the outlier affect the most and the least? So the measure of central tendency, they're just asking about the mean, median, and the mode. So which one was it affecting the most? It didn't change a ton, but it changed a little bit at one point. The mean changed by 1, the median changed by half, and the mode stayed the same. So notice that the mean was affected the most. And since the mode stayed the same, the mode was affected the least. Median changed a little bit, but not too much. Next, what effect does the outlier have on the range and standard deviation? Well, notice that even though we added a small value, the range and standard deviation got bigger. So let's make a note that both the range and the standard deviation increased. So again, even though the value was small, that outlier widened the range of data. So instead of just going, again, like from, what was it, from 11 to 17, now it's going from 3 to 17. So that spread is increasing. So in general, outliers, whether they're small or large, increase the spread of the data. Okay. So now I have something else for you. So that, anyway, that's 11.1. So now I have something else for you to try. I want you to find the mean, median, mode, range, and standard deviation of these data sets. Again, we'll pause and find all of those summary statistics for these. Okay, get ready to pause. Ready, go. Okay, here are the values that we should have. A mean of 15, median of 16, mode of 20, range of 13, standard deviation of about 5.0. Next data set, mean of 25, median of 26, mode of 30, range of 13, standard deviation about 5.0. Now, what do you notice when you compare the original numbers in the data set? Notice they're the same except, well, they're similar, they end on the same value, but notice that each number increased by 10. 7 became 17, 12 became 22, etc. So that's what happened when we compared the original numbers. Now, what happened to the mean? We can see that it increased by 10. That's fun. What happened to the median? Oh my gosh, the median also increased by 10. Wow, I'm seeing a pattern here. What happened to the mode? Oh my goodness, it increased by 10. I bet everything increases by 10. So let's look at the range. What happened to the range? It stays the same. So notice the range remained the same. And what about the standard deviation? That stayed the same too. So notice that the measures of center all changed by 10. But the measures of spread did not. The reason is because when we are increasing by 10, we're moving the center up. We're moving the center from one specific value, we're pushing that center up. But when we talk about the range or even the standard deviation of the values, like if we have values from here to here, and if we bump those values up the same amount, it's that same spread of data, all right? So what happens is this idea, this key concept, happens anytime we add or subtract a constant to data values. When a constant is added, and it can be a negative constant, hence looking like subtraction. So when a constant is added to every value in a data set, the following are true. The mean, median, and mode can be obtained by adding the same constant to the mean, median, and mode of the original data set. So the mean, median, and mode are affected by whatever the constant affected it. But the range and standard deviation are unchanged. They remain the same because that typical distance from the mean is the same for the standard deviation. And that spread of data is the same. The min and max increased or decreased by the same amount, so it's the same spread. So here's how we would give you questions like this. This says, the data below gives the weights of 5 people. At the end of each month, each person had lost 3 pounds. Give the mean, median, mode, range, and standard deviation of the starting weights and the weights at the end of the month. Okay. Well, since we're doing video notes, I'll give you guys a little thing, a little bit of help. Hopefully you feel comfortable finding these different measures of central tendency and dispersion using your calculator. So I'll tell you that these are the values that you would have gotten in your calculator. If you put that in a list, our mean would be 146 pounds, our median 142 pounds, mode 155, range 17 pounds, and the standard deviation is about 5.5 pounds. So notice that this is saying that each person lost 3 pounds. That means that everyone is losing 3 pounds. So we don't have to subtract 3 pounds from each of these to find the new summary statistics, because each person lost 3 pounds. that means that we could take our measures of central tendency and subtract 3 pounds off of each of those summary statistics and get the new summary statistics. And then we look at our measures of spread or dispersion, and we keep those the same. So instead of having to recalculate all this, we can just take the measures of center and subtract 3 from each one. So I get 143 pounds would be the new mean. 139 pounds would be the new median. 152 pounds would be the new mode. And our range remains 17 pounds. And the standard deviation remains 7.5 pounds. So in general, like in these problems, oftentimes we'll give you this data set and then tell you how all the data values changed, and then we'll want you to find the new ones. We didn't really need, if I give you this info, you don't need to know that at all. We just know that the measures of center are affected by that constant, and the measures of dispersion stay the same. Okay? So what would happen, however, if we multiply the data values by something? Well, it turns out if you multiply by something, when each value in a data set is multiplied by a constant, the new mean, median, mode, and range and standard deviation of the new data set can be obtained by multiplying each original statistic by that same constant. And so with multiplication, we change all of them. Okay, so example 2 for this section, remember that the people that were losing weight weighed in with these weights originally. We're going to give the mean, median, mode, range, and standard deviation for the starting weights in kilograms. Well, these are the starting weights in pounds that we found from the other example on the other page. And now we want to find what they are in kilograms. Well, it turns out that 1 pound is 0.45 kilograms. And since all of these are in pounds, that means that we could just multiply each of these by 0.45, and that would give us the starting weights in kilograms. So let's do that. Let's just take 146. This is bugging me. Okay. 146 times 0.45 is 65.7. So I know that my starting weight in kilograms then is 65.7 kilograms. And then you just do that for each of them. We could take 142 times 0.45. And we get 63.9 kilograms. 155 times 0.45. That gives us 69.8 kilograms. 17 times 0.45 gives me 7.7 kilograms. 7.5 times 4.5, 3.4 kilograms. And now we have the mean, median, mode, range, and standard deviation in kilograms. So what you have to remember is that when you're adding or subtracting a constant, we only affect the measures of center and leave the measures of spread alone. But if we're multiplying, they all get affected. Okay, so last is example 3. The summary statistics for original prices of all Fossil smartwatches at a jewelry store are given below. So again, here we're giving you the summary statistics. Now, the store is offering a promotion in which all Fossil watches are 30% off. Find the mean, median, mode, range, and standard deviation of the sale prices. And we'll round to the nearest cent. Well, let's think about what 30% off means. 30% off doesn't mean that we're going to be paying for 30% of it. If it's 30% off, we're really paying for how much of the item? That's right, for 70% of the item. So that means that what we'll do is we're going to multiply the above summary statistics, not by 0.3, but just by 0.7, and that will give us what 70% of the price is. So we could take 311 and multiply by 0.7, and we get 217.7. Well, remember, this is a dollar amount, so I'm going to write it as $217.70. I can do the same thing to 295. Multiply that by 0.7, and I get 206.5, which to the nearest cent means I'll add a 0 for $206.50. Notice the mode is the same, so I am, going to, there we go. Sorry, if you sit too long, the lights go out. So I'm going to keep that same amount. The range, if we take 100 times 0.7, a lot of us knew without our calculator that that was going to be $70. And 34.4 times 0.7 gives me, 24.08. So that'll be $24.08. So that's the gist of what you guys are going to be doing, is just basically using your calculators to find either the summary statistics of original data sets like we did on the first part, making observations about how an outlier affects the summary statistics, and then also being given an original data set, and if we add or subtract, remember that we affect the mean, median, and mode, but leave the range and standard deviation alone. But if we're multiplying, everything is affected, and that's the gist. So enjoy. Hopefully you guys can get some of your homework done. I'll put these up on the website in case you need to rewatch. And you guys have a beautiful day. Thanks. Bye.